Okie dokie. The fun stuff begins. If the past part wasn't fun, which of course I think it was, but if you think the past part wasn't fun, I will tell you that even the more funner part is yet to come. So you're an economist. You believe that economic actors conduct themselves rationally. And generally speaking, what we mean by the word rationally is that they optimize something. They're trying to maximize their utility or maximize their profits or minimize their cost or something, but there's this minimum max calculus going on there, and it really is calculus. And that's what the next 4 chapters are about. 3 in this section and 1 in the last section, I think is how that goes. Maybe 3 in this section and 2 in the last section. It might be 5 chapters. But it's a lot. Okay? Okay, so we're talking about optimization. And the reason we don't say maximization is that optimization can be the maximum or it could be the minimum, right? The optimum cost is the minimum cost. The optimum utility should be the maximum utility. We're looking for an optimal point. Okay? So we have this equation. Profit, revenue, cost. Okay, and there's a minus sign in between. So maximizing profit isn't just maximizing profit. What is it? Well, I'm maximizing the difference between these two things. Okay? Now we can draw graphs of that. And if we do, the revenue of the business, we usually draw something like that. So that would be total revenue. Okay? And again, there's all kinds of, as always, all kinds of assumptions built into this, and hopefully you understand that now. Yes? And then we have a cost function, and our cost function looks something like, well, not exactly like that, but let's just take it like that. Okay? Our cost function is more strongly nonlinear than our revenue function. Our cost function is going to do stuff. And what we're looking for to maximize our profit, right here, this is a loss, right? That would be a loss. The total cost is bigger than the total revenue. Here, in this weird-looking shapy thing, that's where profit happens. Okay? And then here we're back to being a loser. In here, we find that place where there's the biggest difference between revenue and cost, and that will be where we maximize our profits. Okay? Is that exciting? You're like, yeah. Well, it turns out that we can look at this a couple different ways. Is that surprising to you that we can look at this a couple different ways? It's probably not surprising to you that we can look at this a couple different ways. No? Okay. So suppose that we have a revenue and we have a cost, total revenue, total cost. How do we find that point here where there's the biggest difference between them? The answer, it turns out, is going to be the slope of this thing is going to be the same there and there. And that's the place where the maximum occurs, when the slopes of the two lines are the same. So let's go back here. Okay, are we good? now let's take the partial of this with respect to quantity. Total revenue, total cost. Are we excited by that? We ought to be, because this is marginal revenue and this is marginal cost, and that's actually going to be 0. And so if 0 equals marginal revenue minus cost, marginal revenue equals marginal cost. And a little bit of calculus shows us, but the maximum profit point is where marginal revenue equals marginal cost, which hopefully you've learned a bunch of times. Like a bunch of times. Okay? So, some other stuff, we've talked about some of this briefly, but let's talk about it more than briefly. Where is the optimal point on this line? The answer is it's right there. Okay? Is that the optimal point? Yeah, it is. It's at the high point of the line. Now, what do I know? Well, if I draw a tangent at that point, the slope is 0. All right? And again, this is x and this is y. What that means is dy dx at that point is 0. The optimal point, the slope of the line is 0. So we're going to find optimal points, and how are we going to do that? We're going to find them by taking the equations for things and setting them equal to 0 and figuring out what x has to be to make this thing turn out to be, 0. Now, one other little lesson here. What's happening to the slope? Well, let's take this point. The slope there, S-O-P-E, is greater than 0. It's positive, yes? And the slope there is positive, and the slope there is 0. This has a smaller slope. So if I say this is A, B, and C, the slope at A is bigger than the slope at B, which is bigger than 0, which is the slope at C. Okay, are we happy there? We should be. Okay. Yeah. Now, what about that? Well, at C, that's an at sign. At C, the slope equals 0, which is greater than the slope at D. And guess what? Yeah, it's greater than the slope at E. So how is this slope changing? Well, the slope keeps getting smaller. The change in the slope is a negative. As I move from A to B to C to D to E, I can get there by subtracting. I can get there by making the slope smaller and smaller, more and more negative, right? It goes away. It's positive, it heads to 0, and then it goes bigger and bigger negative numbers. So there's a negative change in the slope. You got that? So the slope at this maximum point is 0, and the change in the slope is negative. The change in the slope is the second derivative. Okay? Just remember that. Put that in the back of your mind. We'll get back to that in a second. The change in the slope is the second derivative. So how about this? Here's our optimal point, right? Call that C again. Here's A. Here's B. And what's going on? There's the slope, really negative. There's the slope, less negative. There's the slope, 0. D, the slope is positive. E, the slope is positive and even bigger. So the optimal point here at C, the slope is 0. And the slope is doing what? It's getting bigger. The change in the slope is positive. Every point we move to, the slope is getting larger. There's a positive change in the slope. That's going to help us find a minimum. So this combination is a maximum, 0 and negative change. And this combination is a minimum, 0 slope and a positive change. Okay? Pretty exciting? Okay. Couple other graphs just for the fun of it. Yeah, that's sort of it. Somewhere right in the middle of this is a point where in fact the slope is 0. Okay? Yes? But we don't have the slope, the change in the slope being constantly positive or negative. The change in the slope is changing, right? So here the slope is getting smaller, it's a minus. Here the slope is getting bigger, it's a plus. So this is point A. At A, the slope equals 0. But the change in the slope is both positive and negative depending on where we are. We call that inflection point. Okay? All right? Inflection point. That's one kind of inflection point. And then the other is like this, the opposite. And that point, essentially, there is no point on here where the no slope equals 0. But we change from plus to minus, right, in the slope, right? The slope is getting larger. The change in the slope is positive. Then the change in the slope is negative. That's also an inflection point. But it doesn't have a slope of 0 when we go through there. Okay? How exciting is that? That's like exciting. Yes? Okay. The other thing that's important here is, let's suppose we have a function that looks like this. Okay? Suppose we have a function that looks like that. What do we know about this function? Well, we're going to have a bunch of points that are maximums. And we're going to have a bunch of points that are minimums. So we have a whole bunch of maximums and a whole bunch of minimums. All right? Yes? That point, let's call that A, is the most maximum. Do we all agree on that? That is the most maximum. Okay? That's the global or you might call it the absolute max. These are local or relative maxes. Okay? That's the global or absolute minimum. And that one, and that one are local or relative mins. Okay? If we do a study of this, we could find all of those. And if this is our profit function for some reason, we need to be able to, in the end, sort that one out from the other ones, right? If you're here, you're not really maximizing your profit. You want to be there. Okay? Or it might be that you actually want to be, for some reason, you might be doing something where you want to be on that one, not that. But sometimes there's more than one answer to these alleged problems. Okay?